Welcome to our cosmic journey, a dive into the universe's ultimate fate, where we follow the timeline from the brilliant burst of stars to the whisper of a final silence.
I'm really excited by this topic. It's like we're unfolding the story of everything, right?
Exactly. Imagine a timeline that spans trillions of years, tracking the inevitable decline driven by the laws of thermodynamics.
Absolutely.
The idea isn't science fiction, it's the inevitable conclusion of physics.
Right. And it all comes down to entropy, doesn't it? The universe just marches ever toward disorder.
Yes, entropy is the key. It's like the universe's own accountant, making sure every bit of energy potential gets used up. Every star, every galaxy, all eventually wear down to what we might call a cold, silent
Yeah, that
darkness.
makes sense. So, in simple terms, the bright, active cosmos we see is just a temporary flash before the inevitable decay, isn't it?
Exactly. Think of it like a giant machine. It's like energy is the fuel, and every time that fuel gets burned, the machine's ability to work is diminished. And then, with dark energy accelerating the expansion, things start to drift apart, setting the stage for complete isolation.
Yep, I see that. Speaking of the universe drifting apart, why does this accelerating expansion matter so much in the endgame of everything?
Well, dark energy is really pushing galaxies apart at such a rate that many of them become unreachable, leaving us or any observer in a kind of cosmic island.
That's a kind of isolation we've never experienced before. That isolation means that energy, or even matter, becomes locked away permanently, right? It's like once separated, it can never contribute to any new structure.
Precisely. Energy gradients flatten out, and once the energy is evenly spread, it simply can't do work. It's lost to us forever. That's the one-way street toward total exhaustion.
But wait, isn't there still some gravitational interaction between local groups of galaxies? Aren't structures like our Milky Way still held together in spite of this expansion?
Sure, within local clusters, gravity still plays a strong role.
Yeah, I get that.
But overall, the separation between these clusters increases so dramatically that eventually every isolated group goes its own way. And even those bindings start to weaken over such astronomical timescales.
It's almost like a cosmic farewell party for all structures as they dissolve into nothingness.
Exactly. And stars themselves, think about it, aren't immortal either. The bright blue giants, for instance, burn their fuel in just a few million years. A supernova flash that, while dazzling, leaves behind little that contributes to long-term cosmic endurance.
Yeah, they're like the rock stars of the cosmos. Flashy and short-lived, right? And then you have the red dwarfs, those patient embers that sip their fuel so slowly they might shine for up to 10 trillion years.
Exactly. Our own sun may last about 10 billion years, but these red dwarfs, they're like the marathon runners of the star world, quietly burning away over incomprehensible spans of time.
It's kind of poetic in a way. So eventually, even these slow burners will fade, leaving behind only their remnants.
Yes, over time the stars, including red dwarfs, will essentially dim and transition into what we call black dwarfs, frozen, dense remnants that no longer shine.
Right, that final phase is like the universe's long, silent cooldown. And yet, there's this fascinating idea about a last burst, a rare accidental fusion event if two black dwarfs were to collide. Did you catch that?
Absolutely. Imagining that, it's like the accidental spark of a fire in an otherwise frozen wasteland, a final flash of fusion that momentarily lights up the void before plunging back into darkness.
Yep, it's like a cosmic mic drop moment. That's both awe-inspiring and a little melancholy, isn't it?
Very much so. And then, as the cosmic structures dissolve further, you have the galaxies themselves unraveling as gravity loses its grip and clusters dissolve into a sparse sea of solitary objects.
This brings us to the final titans in this timeline, black holes, which for a long while are the last bastions of mass in the universe.
Right. These black holes, whether they're the remnants of supernovae or the supermassive ones at galactic centers, become the dominant structures of the cosmos. They effectively act as cosmic cleanup crews, drawing in any remaining matter.
I can picture that. But then Stephen Hawking comes in with that mind-blowing twist. Hawking radiation. Which essentially means that even these behemoths aren't eternal.
Exactly. It's like, even the mightiest are subject to decay. In the vacuum at the black hole's event horizon, quantum effects lead to the creation of particle pairs. One falls in, the other escapes, gradually reducing the black hole's mass over incomprehensible timescales.
Exactly. It's such a slow but inevitable process. And the timescale here? It's, astronomical. A black hole like ours might take 10 to the 67th power years to evaporate, while the largest ones could take up to 10 to the 100th power years.
Yeah, these numbers are almost impossible to wrap our heads around. A truly drawn-out cosmic finale.
And once even these behemoths have evaporated, the universe reaches the state known as heat death, a complete thermal equilibrium.
Right. Thermal equilibrium is when every single particle is at the same temperature as every other, with no gradients, no pressure differences. That means, utterly, no energy flows to do any work.
It's the ultimate state of stillness. And with no energy gradients, no new events can occur. It's a frozen picture of the cosmos, with nothing driving change.
Yes, and if nothing happens, then even the concept of time becomes like meaningless. With no before or after, time itself loses all significance.
Yeah, that really flips our understanding of time on its head. I guess it doesn't stop there, does it? There's even the theory of proton decay. So slow that eventually even the very building blocks of matter might dissolve away.
Exactly. Protons, the hearts of atoms, could eventually decay into lighter particles, leading to a universe that's just a sparse soup of photons, neutrinos, and electrons, drifting in an endless cold void.
Yup, it's like the final erasure of every structure. Hearing all that, it really puts our existence into profound perspective. We live in such a brief and lively era compared to this ancient, inevitable decay.
Absolutely. Our cosmic moment is like a brilliant flash amidst a long, quiet twilight. It's a reminder to cherish the vibrant, structured universe we experience now.
So precious. Just think. Every star we see, every breath we take, is part of this brief window between an energetic beginning and an inevitable frozen end.
Precisely. It's as if our universe is a magnificent machine, bustling with energy and structure for a time, but destined to eventually wind down into complete silence. That silence, that dark era, is the default state once all energy gradients flatten out.
And that really drives home, the importance of our moment in time. To appreciate the light and energy we have right now, knowing that change and creation are what make life so miraculous. Thanks for taking this journey through time with me. It leaves you with so much to ponder about the nature of existence itself.